next distribution is the so-called Poisson distribution. Okay, so we shall say x random variable has Poisson distribution with parameter lambda if probability that random variable x has value small x equals lambda to power x over x factorial times e to minus lambda for x equals 0, 1, 2, and so on and so on. Where can we find it? Where can we use it? In many industrial and not only industrial occasions. For example, when something happens quite randomly and during some unit of time or a unit of measure, we expect some number. For example, we have statistics that on average 3 cars come to a gas station during an hour. So we can sum up all the cars that come to the gas station during the year and divide them into hours, okay, into 365 times 24, okay, to have some expected value of cars per given hour or per a day or something like that. So we know that something will occur, and we know the average, the expected value, and we want to ask how likely it will happen, for example, during the next 30 minutes. Okay, but let me give a simple example. 1 per 100 sheep born is black. So we have 1 black sheep among the others. Okay, let it be black. The tail. Okay, and we have a group of 300 sheep. And we want to know the probability at most 2 are black. Okay, how many black sheep do we expect? If 1 out of 100 are black, then in the group of 300 sheep we expect 3 black sheep. Okay, so our expected value lambda is 3. Okay, how do we find this probability? Probability that x is not bigger than 2 equals probability x is equal to 0, so no black sheep, plus probability x equals to 1 black sheep, plus probability x equals 2. Okay, so let's calculate it. We know that x has Poisson distribution with lambda equal 3. In this case, we expect lambda equal 3. And we substitute to the formula, so we have 3 to power 0 over 0 factorial times e to minus 3 plus 3 to power 1 over 1 factorial times e to minus 3 plus 3 to power 2 over 2 factorial e to minus 3. Okay, e to minus 3 appears everywhere, so we can put it in front of the bracket as 1 over e to power 3. 3 to 0 is 1, and this is 1, so we have 1 plus 3 divided by 1, which is 3. This is 9 over 2, which is 4.5. Okay, so this is 4.5 plus 3 plus 1. This is 8.5. So this is equal to 8.5 divided by e to power 3. So this is about 8.5 over 2 72 to power 3. Okay, and this is about 0, 4, 2, and 2. Next example. She is gone. Now we have Jim has a gas station. Jim has a gas station in Ohio, and the station is passed by about 120 cars per 24 hours on average. Okay, and we have to find probability first step. No cars within the next hour. Question B. There will be at least one car within the next hour. C. At least 3 cars within 30 minutes. So we have a different period of time now. At most 1 car within next 2 hours. Okay, so question A. What is the expected value, the lambda value? In 24 hours it's 120, so we have to divide, and this is 5 cars per hour. So we expect 5 cars per hour on average. Okay, so in this case we expect 5 cars. So what's the probability? There will be no cars. So this is probability that x will be 0. So this is 5 to 0 over 0 factorial e to minus 5. So 1 over e to 5. This is about 0.007. Okay, question B. There will be at least 1 car. At least 1 car. Probability that x will be greater equal 1. Okay, now this is exactly as 1 minus probability that x will be equal to 0. Okay, so we have 1 minus 0.007, so this is 0.993. Okay, C. Now let's observe, the situation has changed because we have only 30 minutes, so we don't expect 5 cars. How much do we expect? We have to find a new lambda. Now lambda is, well, half of the 5, so we have 2.5. Okay, this is only a half of the previous case. So at least 3 cars, probability that x will be greater equal 3. So it means 1 minus probability that x will be less equal 2. So it was 1 minus probability x equals 0 minus probability x equal 1 minus probability x equal 2. Okay, so let's substitute. 1 minus 2.5 to 0 over 0 factorial times e to minus 2.5 minus 2.5 to 1 over 1 factorial e to minus 2.5 minus 2.5 to 2 over 2 factorial e to minus 2.5. So this is 1 minus e to minus 2.5, and we have 1 minus 2.5 plus 2.5 plus 625 divided by 4 by 2 divided by 2. And this is about, these are calculations and calculations. And what do we get in this case?